Hey, I'm Greg, founder and CEO of Oxen.ai, and today I wanted to give you a quick walkthrough of what Oxen is and how you can use it to leverage and improve machine learning models at scale in a data-driven approach. At its core, Oxen looks a lot like Git and GitHub, and that's intentional. We wanted to make collaborating on the datasets that went into these machine learning models as easy as collaborating on code. Where you'll see the big difference is the size and scale that Oxen can handle. For example, here we have all of ImageNet, which is 140 gigabytes of data and 1.2 million data files, particularly images. This is the type of data that you would never check into a Git or GitHub repository. And there's tools like GitLFS that can extend Git, but they're really not that performant when it comes to machine learning data sets. We also auto-detect the type of files that are in your repository, and when it comes to any structured data files or anything that we can render within the UI, we automatically pull it in and make it really easy for you to view your data. One of the most important things while building machine learning models is looking at the inputs and outputs of data. Not only do we make it easy to view your data, we allow you to query it in natural language or even edit it directly within the UI. Here you can see somebody came in and they already added this labels column. So if you just wanted to do some by hand labeling, we have a easy interface for saying this is a bookshelf. We automatically detect the rows that have changed and the columns that have changed before you commit it into your data set. You can commit it to the main branch, make new branches, just how you do in Git and GitHub, but really optimized for these larger multimodal machine learning data sets. The reason we do this is we want you to be able to test machine learning models at scale on a wide variety of data. It's one thing to write a one-off prompt and test it on a few data points. It's another to take an entire data set, run a model on it, and either evaluate how well it did or just use those raw outputs in a downstream process. For example, let's take this financial sentiment data set. Here, it's not a huge data set, but we have 4,000 rows of different news articles and titles. Now, granted, these ones are already labeled, but imagine you didn't have labels or you're just using the labels as a ground truth for an evaluation. You can come up here and use this little rocket ship icon, and Oxen.ai has all of the state-of-the-art models as providers that you can directly run on your data within the UI. So here we have OpenAI. Maybe let's try Google, or I like open source, so we have a few of the Llama models here. We'll take Llama 3.1 7db instruct, and let's try to get it to do sentiment analysis on this data set and look at the results. So I'm going to title this evaluation sentiment analysis, and I'm just going to talk to it in natural language. I'm going to say, classify the following text into positive, negative, or neutral based on the sentiment of the text. We use similar to the handlebars syntax here, and you can take pretty much any columns in your data set as long as it's text, soon images, soon audio, and we'll generate a new output column given the data and the prompt above. Let's run a sample to see how well Llama 3.1 7db works on this. Now, as a first run, you can see the model was a bit verbose. It described its whole thought process. It did say which category it was in. It was honestly looks like it was wrong on this one, but I want it to yap a little bit less, and let's say all lowercase one word before we go ahead and kick this off on the full data set. Okay, that looks a much more reasonable, and honestly, it got this first one right instead of wrong this time. So once you're feeling good about your prompt, feeling good about your model, you can click next. And what's cool about Oxen is it's the same like branching and merging workflow that you're used to for code. So we could YOLO this and commit it directly back to the main branch, but I'm going to say evaluating sentiment in Llama. Which one was this? 7db, I think. And then you can type your commit message just like you would in code. You can also do all of this from the command line and from our developer tools, so check out the docs if that's interesting to you. But I like to kick around models directly in the UI here. It makes it really easy. and we'll say sentiment with llama 70B. Go ahead and kick off this evaluation. Now we call it evaluations. It could just be used for synthetic data, doing your first pass of labeling on the data set. And you can see as it's running, we're computing the total tokens used, we're estimating how much this full run will cost. In this case, the 4,000 rows is only going to cost about 20 cents because we're using the Fireworks as the provider. And you can go to our models page here, see all the different models that we provide, the input and output token prices. But we kind of try to give you an estimate as the model's running so you can kind of see how much this job is going to cost. Now, this is going to take a little bit to run on all of the data, so I do have some pre-baked ones already in here. Let's look at how GPT-4o performed on this task. So you can see this is a finished run. In this case, it was on the test set, and so we just did 1,000 rows. Cost about 20 cents, and we saved the results to the branch sentiment analysis GPT-4o and the test.parquet file. So now we have all of our results in this resulting file. You can see there's been 30 different commits on this file, on this branch, so I've done a bunch of different testing with different prompts. But what's cool is you can even come in here and directly query your data as well as looking at the individual rows. So in this case, I probably want to know what is the accuracy of the prediction given the sentiment. What's cool is we don't make you remember SQL. We don't make you write the SQL. You just have to write a natural language in that query bar. We'll translate it to SQL under the hood, and for sure, I don't know if I could remember that one off the top of my head. But look, GPT-4o seemed to get 70% accuracy on this task. Maybe let's break it down per category. What's the accuracy of the prediction giving the sentiment per category? I don't know if this will work, but it's always fun to try. Okay, cool. So it broke it down into positive, negative, and neutral. And you can see the negative, we actually get 93% accuracy on. Neutral 80, and it's kind of struggling with the positive sentiment category. So show me all the rows where prediction is positive and sentiment is not positive. This should show us all of those rows where prediction equals positive and sentiment not equals positive. You could sort by the text if you wanted to, and do a little debugging and do a little thinking of like, hey, how could we tweak the prompt to make this a bit better? So that was kind of a whirlwind tour of what Oxen is. You can put data of all shapes and sizes, small data sets, large data sets. You may be evaluating RAG pipelines. You may be doing computer vision. The models that we support today are image to text, image to embeddings. We're working on text to text, text to embedding. We're working on image to text, image to embedding, video to embedding, all this kind of stuff. We give you $10 of compute credits when you sign up. So feel free to try any of these models on your data sets. Use a workflow that you know and love, commit, branch, merge, and let us know what you think. We found it a useful tool for even iterating on that text to SQL pipeline that I showed you there. So excited to see what you build. Thanks.